A few more frontier topics of my own choosing. The first of which is computing. Computational physics has come a very long way in the last couple of decades. And part of the reason for that is that the hardware has improved very rapidly and continues to do so. The software has also improved very rapidly and continues to do so. The use of parallel computing will expand ever more, and quantum computing is on the sort of mid-horizon, somewhere in the 20 to 30 year range for a practical, widely distributed system. So that's out there, and that's going to lead to all kinds of breakthroughs in the context of science, particularly in the areas of analyzing large molecules, DNA, RNA, and protein. The secondary and tertiary effects of the electric potentials are going to be much better understood. So the way that genetics and protein interact with each other is going to be much better understood, which presumably will make us much more capable of dealing with things like viruses and antibiotic-resistant bacteria. That takes time. It's not something that's going to happen next year, but it's definitely something that's on the horizon for the span of your careers. Another thing which I have been told, but I've been told so in a convincing manner, the resolution for both MRIs and ultrasound are going to increase by orders of magnitude, and in fact already have in certain research environments, but that's going to be trickling down into the general medical population sometime in the next 10 to 15 years. 1 to 2 orders of magnitude of increase in detail resolution is going to revolutionize medicine, particularly in terms of treatment of tumors and blood flow issues. Commercial fusion will be possible sometime in the next decade to decade and a half, and will actually begin to happen probably in about 2 decades. The Germans have been very successful with their ignition experiments in the last 3 to 5 years, and the French and Japanese have a project which is building on that success with ignition that is going to come online in a research reactor sometime near the end of the decade, and then within another decade it will be commercially practical. I have always said, and actually believe, that success in commercial fusion is going to change mankind about the same amount that fire did. It is that revolutionary of a step in our ability to produce and manipulate energy. It's going to change the world in very fundamental ways. Something totally unexpected is going to be observed in cosmology. This happens literally every time somebody turns on a new telescope. We know quite a bit about the very, very beginning because we can look at the cosmic microwave background radiation that was discussed in part 1 of this chapter. But there's a whole intermediate period of time that not much is known about because the resolution, when you look that far back in time, is not yet good. And every time we improve telescope technology, we get a better view of that intermediate level. We observe new phenomenon that nobody ever expected. Supermassive black holes, when I was a graduate student, were extremely speculative, and most serious cosmologists would have said non-existent. And now we know that there are definitely tens of billions, because almost every single galaxy has a supermassive black hole at its center. So, totally unexpected things happen all the time in cosmology. It's a very live field. And the last one is something I'm pretty sure is going to happen because we're finally looking in a more realistic way. Some non-terrestrial life is going to be observed. And I don't mean somebody's going to show up in a spaceship. I mean somebody's going to find a lichen on a moon somewhere near one of the outer gas giants. The distances involved and the limitations of relativity make actual interstellar, much less intergalactic, space travel extremely unlikely to be possible. And certainly not in the sense that somebody flies by, plays a couple of pranks on a cow, and probes some drunk guy in Iowa, and then flies away never to be seen again. The amount of effort that it's going to take to get here is so large in comparison that clearly none of that is real. Nobody who could get here would bother to do that. But the presence of life elsewhere, because of the way self-organizing molecules seem to work, seems pretty inevitable. And the evidence for it is going to be subtle, but our tools for looking at it are getting significantly better all the time. So that's what I think is going to happen at some point in your lifetime. Most of those things will be big news if they happen, and won't be if they don't. But I hope at some point you come back and go, ha, totally wrong about that. And that's fine. Take care, and good luck.